In this part, we're going to be adding, subtracting, dividing, and doing something called rationalizing square roots. So make sure you've watched part 1, and let's hop all the way down to adding and subtracting right here. We can add and subtract radicals only if they have the same number under the radical. What does that mean? Well, you might remember a good analogy from Algebra 1. Think about this expression for a second. It's not in your notes, so just watch. If you were to simplify this expression, you might combine like terms. And you could only be able to combine the terms that have the same variables, such as this 3x and this 4x. Combining them would give you 7x. Or, for example, this 5y and this 2y. They both have the y, and combining them would yield another 7y. Or this lonely 7 all by itself with no variables with it would just be another 7. Remember, this is combining like terms with variables. And actually, when we're adding and subtracting radicals, it's the same exact thing. Adding and subtracting radicals is just like combining like terms, because we can only add and subtract radicals if they have the same number under that radical. So take a look at this first example here. 3 square root 2 minus square root 2 plus 4 square root 3. It might be a little easier to put a 1 in front of the square root of 2 as a coefficient. Now we can look. Just like terms, we can think about this number under the square root as almost like a variable. We're going to be allowed to combine this radical with this radical because they both have a square root of 2 under the square root symbol. But we will not be able to combine this term because it has a square root of 3. So let's take a look. 3 square root of 2 minus 1 square root of 2 is 2 square root of 2's. Just like when we're combining like terms with variables, we're adding these coefficients out in front. 3, in this case subtracting, 3 minus 1 is 2 square root of 2's. Plus, well, there's nothing to combine this 4 square root of 3 with, so we'll just tack that right onto the end. 2 square root of 2 plus 4 square root of 3. Easy as that. The second example here, well, we've got a square root of 5 and a square root of 45. Can we combine those? Well, it looks like we can't. But wait a second. Maybe the square root of 45 isn't simplified all the way, and we'll have to simplify it before we can actually decide whether to add them together or not. So let's go ahead and simplify first. The 2 square root of 5, that's already simplified. No perfect squares, divide 5. However, 45 does need to be simplified. Think about it from before. Which of our perfect squares divides 45? 9 does. 9 divides 45. So we can write this. 2, and then the square root of 45 breaks into the square root of 9 and the leftovers, which is the square root of 5. 9 times 5 is 45. We can't divide anything else out of the square root of 5, so we'll just write 2 times the square root of 9 is 3. That's been freed from the radical and the 5. So this is really 6 square root of 5. Look at this. Square root of 5, square root of 5. If we just bring down the 2 square root of 5 plus 6 square root of 5, well, now we can see they do have the same number to the square root, and we now can add them together. 2 square root of 5's plus 6 square root of 5's yields 8 square roots of 5. If you're feeling pretty good about these last two examples, pause the video now and try the third one. Then unpause to see if you're right. Pause the video now. All right, let's take a look. You might look at this and say, okay, well, we can't add or subtract those because there's not the same number under that radical. No, definitely not at all. But wait, maybe we can simplify one of these. The square root of 6, that's already simplified as it can go. No perfect square divides 6. However, there are perfect squares that divide 24. Which perfect square is that? I think it's going to be 4. 4 divides 24. Let's take a look. So we can break this number down, the 24, into the square root of 4 and the square root of 6, because 4 times 6 is 24, and 4 is what we're trying to take out. Bring down that 2. And there's nothing else we can do with the square root of 6. That's as far as I can go. So the square root of 4 is 2. Bring down the square root of 6. Negative 2 times 2 is negative 4. Square root 6. Oh, and this is a good thing now, because look at this. Bring down this our square root of 6 from the beginning, and now we have negative 4 square root of 6 minus, I guess we'd call that a 1 square root of 6. Negative 4 minus 1 gives me negative 5 square root of 6. So actually, adding and subtracting radicals, or square roots, is quite straightforward. Simplify them if you can. Simplify if you can. And then once you're done, ask yourself, are there any terms with the same numbers under the radical, under the square root? If there are, like 5 and 5, then you can add their coefficients together. 2 plus 6 is 8. If there aren't, for example, like the square root of 2 and the square root of 3, then you cannot add those together. We've learned how to multiply, add, subtract, simplify everything. We've got one last thing to do. What about dividing radicals? Well, dividing radicals is a lot like multiplying radicals. What I mean by that is, remember back when we multiplied radicals together, we were able to multiply the coefficients outside the square root together, such as 5 and 5, to get 25, and the values under the square root, such as 6 and 2, to get 12, and then we simplified. The same thing can be said for dividing. Take a look at this first example. The square root of 15 divided by the square root of 3. Since they're both under the radical, under the square root, it can be rewritten as the square root of 15 divided by the square root of 3. And we know that 15 divided by 3 is 5. So this is the square root of 5. The square root of 5, or 5, has no perfect square factors, so it cannot be simplified, and that's where it ends. Similarly, take a look at the second example. We've got 4 over 4, and the square root of 6 over the square root of 3. This can be rewritten as 4 divided by 4 times 6 over 3. Now we know that 4 over 4 is just 1, and 6 over 3 is 2. This can be rewritten as 1 square root 2. And since the number 1 out in front isn't quite necessary, because 1 times anything is just itself, this can be rewritten as the square root of 2. There is just one issue. Often we don't like to have an irrational number in the denominator. In other words, we don't want to have a radical in the bottom of a fraction. So something like this right here, where there's a square root of 2 in the denominator of this fraction, is not acceptable. And we'll talk about why it's not always the best thing in class, and why we might not want this. But for now, let's talk about how to fix this. We're going to do something called rationalize the denominator in order to get the square root out of the denominator. Here's what we're going to do. Remember when we talked about squaring square roots and how they canceled out the square, right? We're going to use this technique with the fraction to try and cancel out the square root in the denominator of a fraction. Take a look at this. If we take this fraction right here, 3 over the square root of 2, and we multiply both the top and the bottom of that fraction by the square root of 2, remember we can do this because I can multiply the top and the bottom of a fraction by the same number, because the square root of 2 over the square root of 2 is just 1, and that doesn't change the value here. In any case, if we multiply the top and the bottom by the square root of 2, let's see what happens. The top, well, the numerator, that's just 3 square root of 2. But the denominator, the square root of 2 times the square root of 2, is the square root of 4. And the square root of 4 doesn't have to be a square root at all. The square root of 4 is just 2. And now look, we no longer have a radical, or a square root, in the denominator. Now it's just the number 2. We can do the same kind of thing with the second example here, 3 over 2 square root of 5. What I can do is multiply both the numerator and the denominator by the square root of 5. Because remember, when I multiply square root by itself, it's going to cancel it out. So multiply the top and the bottom by the square root of 5. Okay? 3 times the square root of 5 is 3 square root of 5. In the denominator, 2 square root of 5 times square root of 5, where we can multiply those numbers under the radical to get 25. Multiply the numbers outside the radical, just the 2. Okay? And then the square root of 25, well, that's just 5. And the 2. And the numerator, the 3 square root of 5. And 2 times 5 is just 15. 10, sorry. 2 times 5 is 10. And the numerator, 3 square root of 5. So again, we notice that there's no longer a radical or square root in the denominator. If you're feeling pretty comfortable with what we've done so far, pause the video now and try the third example. Pause the video now, and now we'll take a look at it, right? So again, square root of 5 in the denominator to try and rationalize, or get rid of that square root. We can multiply the numerator and the denominator by the square root of 5. On the top we have 3 square root of 5. On the bottom we have the square root of 25, which is just 5. And luckily there's no longer a square root in the bottom. Again, this is called rationalizing, and this is when you do not want to have a square root in your denominator, kind of like we've had in these past examples.